Welcome back to class. In today's class, we'll be looking at a new topic in chemistry, and that topic is gas laws. What are the things we're going to look at under gas laws? We will look at an introduction to gas laws. We will talk about the Boyle's law, Charles's law, Gay-Lussac's law, general gas law, ideal gas law, Graham's law of diffusion, Avogadro's law, and then Dalton's law of partial pressure. Now let's get started. What is a gas? A gas can be defined as one of the physical states of matter whose molecules or atoms move freely throughout the whole space. You see, we have four states of matter. What are these four states of matter? We have solid, liquid, gas, and plasma. Plasma is the fourth state of matter. Now, gas is one of those states of matter, and in a gas, the molecules are far apart. They move very freely. They are not constricted. They are not restricted. The molecules can vibrate very, very fast, and they move very apart. So that's what a gas is all about. So the gas molecules take the shape of the container in which they are kept. The gas molecules, that is, whatever container you put them, that is the shape they will also assume. If you put the gas inside, let us say, a circular bowl or a circular container, then the gas will take the shape of a circular container. If you put the gas inside a rectangular container, then the shape of the gas will be the rectangular container. That is, the shape of the gas is dependent on the container holding or housing the gas. A gas does not have a fixed shape. It's just like a liquid. A liquid also does not have a fixed shape. It takes the shape of the container. And also, a gas does not have a fixed volume. A gas does not have a fixed volume. That is, the volume of a gas is not fixed. It depends on the volume of the container that you're putting the gas into. For instance, if the volume of the container, the highest capacity of the container, let us say, is like 1000 meter cube, that means that the highest amount of gas that can enter into that container is also 1000 meter cube, because that's the highest capacity of the container. So that means the volume of the gas depends on the container. A gas does not have a fixed volume. A gas by itself does not have a fixed volume. It depends on the volume of the container. So that's why we say that a gas has no fixed shape and it has no fixed volume. Now, a gas could be an element, and then examples of gases as elements are, we have hydrogen gas. Hydrogen gas is written as H2. It's a gas, hydrogen gas. We have oxygen gas, O2. Why do we have these two there? We have two there to tell you that it is a diatomic gas. What is a diatomic gas? A diatomic gas is a gas that contains two atoms of that element in one molecule of it. That is, in H2, we have two atoms of hydrogen. That is, one atom of hydrogen, another atom of hydrogen. Both of them combined together becomes one molecule of hydrogen gas. That's why we write H2. The same thing with O2. O2 is also a diatomic gas. That is, we have two atoms of oxygen coming together to form one molecule of oxygen gas. The same thing applies to chlorine gas, Cl2, iodine gas, I2. All these gases I mentioned, they exist as elements. They are elemental gases because they are existing at the element stage. Then we also have a gas to be a compound. A gas could as well be a compound. What is a compound? A compound is the combination of two or more elements chemically combined together. A compound is when two or more elements are combined together chemically, and they cannot be separated by any physical means or any known ordinary chemical reaction. So now, for this compound, what do we know? We said examples of gases as compound. Examples of gases as compound. One, we have carbon dioxide. Carbon dioxide is a gas, and it contains two major elements. What are those two elements? Carbon and oxygen. So carbon dioxide is an example of a gas at a compound level, at a compound stage. And carbon dioxide is simply the air that we breathe out. You know, we take in oxygen gas and then we breathe out carbon dioxide gas. Carbon dioxide is also the same thing as carbon dioxide. So it is a gas. And when you open your soft drink, if you first of all shake the bottle of your soft drink and then you open it, you hear a shrilling sound. You hear something like shh. That shh that you heard is because carbon dioxide is trying to escape. So carbon dioxide is trying to escape the liquid, the soft drink, and by doing so, it creates what we call effervescence. But what I want you to know is that carbon dioxide is a gas. Later on, we'll talk about the characteristics of carbon dioxide. Then we also have hydrogen chloride. Hydrogen chloride is a gas. That is, it is the combination of hydrogen and chlorine. When you bring both of them together, you have hydrogen chloride gas. Then we also have hydrogen sulfide gas, the combination of hydrogen and sulfur. That's hydrogen sulfide. It is a gas. And this one thing about this hydrogen sulfide is that it has a rotten egg smell. It smells like rotten egg. It has a choking smell, a very bad stench. That's one thing about hydrogen sulfide. Then we also have ammonia. Ammonia too is a gas. And what is ammonia? Ammonia is a combination of what? Nitrogen and hydrogen. So we are combining two elements together, nitrogen and hydrogen. So ammonia is a gas. Ammonia also has a very bad smell. It smells like urine, like concentrated urine, and then it has a choking smell, a repugnant smell. So now let us look at the characteristics of gases. What are the characteristics of gases? Number one, they have no fixed volume but expand to take any available space to them. One thing about gases is that they don't have a fixed volume. They only depend on the volume of their container. Whatever is the volume of the container, they also assume that volume. They don't have a fixed volume. And for you to fill up that container to its brim, it means that that is the highest capacity of gas that can go into there. So they have a fixed volume, and they have no fixed volume. I mean to say, they have no fixed volume, and they always expand. Gases expand. Why do they expand? Because the molecules of the gases are very far apart. They are free to move. The molecules are very much free to move, and so they are ready to take up any space available to them. For instance, if I introduce ammonia gas into this environment, what will happen? The ammonia gas will spread out. It will expand. It will spread out and take any available space to reach. And then you can perceive the smell of ammonia all over the place because it has expanded. Number two is that they have no fixed shape. All gases do not have a shape. They don't have a shape at all. They have no fixed shape. They may take the shape of the container just like a liquid, but a gas typically does not have any shape at all. It does not have any shape. It has no fixed shape. Number three is that they can be compressed easily by applying pressure. Another thing about gases is that you can compress them. To compress them means to apply pressure to them. And when you apply pressure to them, what happens? They become compressed, and they can, if you apply enough pressure, they can be compressed to liquid. Gases can be compressed. Some gases can be compressed. They are highly compressible. You can compress them to liquid. Then number four is that they diffuse rapidly in all directions. Gases move rapidly, and they don't have a specific direction. They move randomly. They can go all over the place. For instance, when you open your cylinder, your cooking cylinder, what happens? The gases will come out at a very high speed and diffuse rapidly in all directions. That is one of the characteristics of gases. And number five is that when heated, they expand. When you heat the gas molecules, they gain more energy, and by gaining more energy, they vibrate more violently, and then they expand all over the places. Gases expand all over the places. So these are the characteristics of gas, and this is an introduction to gas laws.